applications of trigonometry. Introduction. In this chapter, we shall make use of trigonometric ratios to find the height of the tree or a tower, width of a river, etc., distance of a ship in sea from a lighthouse, angles of elevation and depression. Angle of elevation. Suppose O be the position of the observer and P be the position of the object to be observed by the observer. P is at a height lower than O. The horizontal OQ drawn through O meets the vertical line drawn from P at the point Q. The angle POQ is called the angle of elevation of the object at P as observed from O. Angle of depression. Here, the position of the observer is at P and at a higher level than the position of the object. PX is the horizontal line drawn through P. PO is the line of observation. The angle OPX is called angle of depression of the object at O as observed from P. Now, if we draw a vertical line PQ through P, it meets the horizontal line drawn through at the point Q. Now, we find that angle OPQ is equal to angle POX.
Concept of angle of elevation and angle of depression. H by x equal to tan theta, h equal to x tan theta, x equal to h cot theta. If OP equal to 1, then h by L equal to sin theta and x by L equal to cos theta. H equal to 1 sin theta, x equal to 1 cos theta. From a point on the ground 15 meter away from the root of a tree, the angle of elevation of the top of the tree is 30 degree. Find the height of the tree. Solution. Let P be the top of the tree and Q be its root. We are given OQ is equal to 15 meter and angle POQ is equal to 30 degree. Let us take the height PQ as h meters. Now in the right angle triangle POQ, PQ by OQ is equal to tan 30 degree. That is h by 15 is equal to 1 by root 3, implies root 3h is equal to 15. We get h is equal to 8.66. Therefore, the height of the tree is 8.66 meter. A circus artist is climbing from the ground along a rope stretched from the top of a vertical pole and tied at the ground. The height of the pole is 12 meter and the angle made by the rope with the ground level is 30 degree. Calculate the distance covered by the artist in climbing to the top of the pole. Solution. We are given that the height of the pole as 12 meter, that is PQ is equal to 12 meter. P is the top of the pole PQ and distance covered OP is equal to L. We are also given that angle POQ is equal to 30 degree. In right triangle OQP, PQ by OP is equal to sin 30 degree. That is 12 by L is equal to 1 by 2, implies L is equal to 12 into 2 is equal to 24 meter. The distance covered by the artist in climbing to the top of the pole is 24 meters. The angle of the elevation of the top of the unfinished tower at a point distant 100 meter from its base is 45 degree. How much higher must the tower be raised so that its angle of elevation at the same point may be 60 degree? Solution. Let PQ is equal to h meters be the height of the unfinished tower. From the figure, angle POQ is equal to 45 degree and we are given that OQ is equal to 100 meter. Suppose the required height raised be PR is equal to y meters. Then RQ is equal to h plus y meter. In triangle OPQ, h by 100 is equal to tan 45. H by 100 is equal to 1, implies h is equal to 100 meter. H plus y by 100 is equal to tan 60 degree, implies h plus y by 100 is equal to root 3. H plus y is equal to root 3 into 100. Substituting the values of h, we get y is equal to 73.2 meter. Thus, the height of the tower to be raised is equal to 73.2 meter. A tree stands vertically on the bank of a river. From a point on the other bank, directly opposite the tree, the angle of elevation of the top of the tree is 60 degree. From a point 20 meter behind this point on the same bank, the angle of elevation of the top of the tree is 30 degree. Find the height of the tree and width of the river. Solution. Let PQ is equal to h meters be the height of the tree. P is its top. Angle PAQ is equal to 60 degree. Suppose the width of the river be x meters, then AQ is equal to x meter. BA is equal to 20 meter and angle PBQ is equal to 30 degree. In triangle PAQ, h by x is equal to tan 60 degree, implies h is equal to x into root 3. Let us denote this by equation 1. In triangle PBQ, h by x plus 20 is equal to tan 30 degree, implies h is equal to 1 by root 3 into x plus 20. Let us denote this by equation 2. Equating 1 and 2, we get x into root 3 is equal to 1 by root 3 into x plus 20. X into root 3 square is equal to x plus 20. X into 3 is equal to x plus 20. 2x is equal to 20, implies x is equal to 10 meter. Therefore, width of the river is 10 meter and height of the tree is equal to 10 into root 3 is equal to 17.3 meters. From the top of a cliff 60 meters high, the angle of the depression of the top and bottom of a tower are observed to be 45 degree and 60 degree. Find the height of the tower. Solution. Let PQ is equal to 60 meter be the height of the cliff. P is the top of the cliff. PX is horizontal line through the point of observation AB in front of the cliff. Let us take AB is equal to h meters and BQ is equal to x meters. From the figure, angle APX is equal to 45 degree and angle BPX is equal to 60 degree. Angle PAC is equal to 45 degree. AC is perpendicular to PQ. Angle PBQ is equal to 60 degree. In triangle PBQ, tan 60 degree is equal to PQ by BQ implies root 3 is equal to 60 by BQ, implies BQ is equal to 20 into root 3. Now, in triangle PAC, CP by AC is equal to tan 45 degree, implies CP by 20 root 3 is equal to 1, implies CP is equal to 20 root 3. 60 minus x is equal to 20 into 1.73. 60 minus 34.6 is equal to x. Therefore, x is equal to 25.4 meter. Therefore, the height of the tower is 25.4 meter. As observed from the top of the lighthouse 100 meter high above the sea level, the angle of the depression of a ship sailing directly towards it changes 30 degree to 45 degree. Determine the distance travelled by the ship during the period of observation. Solution. P is the top of the lighthouse PQ. We are given that its height PQ is equal to 100 meter. PX is horizontal line through P. Angle APX is equal to 30 degree. Angle BPX is equal to 45 degree is equal to angle PBQ is equal to angle PAQ. Let us take AB is equal to x and BQ is equal to y meters. In triangle PBQ is equal to PQ by BQ is equal to tan 45 degree. That is 100 by y is equal to 1. Implies y is equal to 100 meter. In triangle PAQ is equal to PQ by AQ is equal to tan 30 degree. That is 100 by x plus y is equal to 1 by root 3 implies 100 by x plus 100 is equal to 1 by root 3 implies 100 into root 3 is equal to x plus 100. We get x is equal to 73.2. Therefore, AQ is equal to x plus y is equal to 73.2 meter plus 100 meter is equal to 173.2 meter. Therefore, the distance travelled by the ship during the period of observation is equal to 73.2 meter. A pole 5 meter high is fixed on the top of the tower. The angle of elevation of the top of the pole observed from a point A on the ground is 60 degree and the angle of depression of the point A from the top of the tower is 45 degree. Find the height of the tower. Solution. P is the top of the tower, PQ. Pole PR is equal to 5 meter. PX is horizontal line through P. Angle RAQ is equal to 60 degree. Angle XPA is equal to angle PAQ is equal to 45 degree. Let us take PQ is equal to H meters and AQ is equal to X meters. In triangle PAQ is equal to PQ by AQ is equal to tan 45 degree implies H by X is equal to 1 implies H is equal to X. In triangle RAQ is equal to RQ by AQ is equal to tan 60 degree implies 5 plus H by X is equal to root 3 implies 5 plus H is equal to X into root 3 implies 5 plus X is equal to X root 3. Substituting the values, we get X is equal to 6.83 meter. Therefore, the height of the tower is 6.83 meter. A vertical tower stands on a horizontal plane and is surmounted by a vertical flagstaff of height h. At a point on the plane, the angle of elevation of the bottom and the top of the flag are alpha and beta respectively. Prove that the height of the tower is h tan alpha by tan beta minus tan alpha. Solution. Let PQ is equal to h be the height of the tower. PR is equal to G is the height of the flag staff. Angle PAQ is equal to alpha. Angle RAQ is equal to beta. AQ is equal to X. H by X is equal to tan alpha. Implies H is equal to X tan alpha. Let us denote this by equation 1. H plus G by X is equal to tan beta. Implies H plus G is equal to X tan beta. Let us denote this by equation 2. Equating 1 and 2, we get H plus G by H is equal to X tan beta by X tan alpha. Dividing 2 and 1, we get tan alpha into H plus G is equal to H tan beta. Tan alpha H plus tan alpha G is equal to H tan beta. Implies H into tan beta minus tan alpha is equal to H tan alpha. Implies H is equal to H tan alpha by tan beta minus tan alpha, which is the required proof.